Hi everybody, this is Eureka Math Module 1, Lesson 5. Our essential question is, how can I tell if two quantities are proportional to each other by graphing on a coordinate plane? If you have a ruler or a straight edge close by, we're going to use that later on in the lesson. So it's okay if it's not a ruler, just something to draw a straight line to keep our work nice and neat. Okay, if you've written down the essential question, keep going. Isaiah sold candy bars to help raise money for his scouting troop. The table shows the amount of candy he sold compared to the money he received. Is the amount of candy bars sold proportional to the money Isaiah received? How do you know? Well, we can tell that this is in a table, and we're pretty good now at telling if something is proportional in a table. What you can do is you can do the money divided by the bars and see if it is proportional. So let's go ahead and do that. 3 divided by 2. You always want your calculator out. Please do not just watch this and write it down without trying it yourself. There's a big difference between copying without thinking and actually typing in $3 divided by 2 candy bars, and that would be $1.50 each, or 1.5. Then we could do $5 divided by 4 candy bars. That is not 1.5, that's 1.25. Okay, it also says that for 8 candy bars sold, $9. Well, 9 divided by 8 is going to give us an even different number. And you can keep going, but it's already obvious to us that no, it is not proportional because there is no constant multiple. So underline the question part. It says, is the amount of candy bars sold proportional to the amount of money Isaiah received? How do you know? So no, because there is no constant multiple. And anytime you want to justify or back up your answer, you can explain it in words, or you can show right here that these are the different multiples. There's not a constant multiple. Okay, that was just an opening exercise. The first example in your lesson today is going to be going from a table of candy bars and money to a graph here. Now this one says, use the ratio provided, create a table that shows that money received is proportional. Mark the text there. It is proportional. So money is proportional to the number of candy bars sold. With that said, if 2 candy bars sold is $3, well, I can use a constant multiple. I can double both of those. And I can say that 4 candy bars sold is $6. Okay, just to show you, that was 2 times 2 is 4, so 3 times 2 is 6. But we want to keep going, so now we can do 2 times 3 is 6, and 3 times 3 is 9. And again, you can multiply again. This time we can multiply the original by 4, so 2 times 4 is 8, and 3 times 4 is 12. Now, if you noticed up in the opening exercise, when we did the money divided by the candy bars, we were getting different numbers. This time, we will get the same number because 3 divided by 2 is equal to 6 divided by 4, which is 9 divided by 6, and 12 divided by 8. They all equal the same thing. Write it in your calculator. Type it in right now. I don't want you to just wait for me to say it. Go ahead, pause it, type it in, see what you get. Okay, once you did that, once you paused it and typed them all in, you should have gotten all of those to be 1.5. That's going to mean something later, so let's leave that there for now. The first thing we're going to do is graph. Do you remember how to plot points? X first, that's across, then Y, which is up and down. How do I know which one is the X and which one is the Y? Which one do you think makes more sense here? Should the X candy bar sold be going across or up and down? Here's another way to think about it. If you're going to buy candy bars, do the candy bars determine the price, or does the price determine the candy bars? We're going to think of it this way, where X is the candy bars sold. however many I sell, that will determine my price, and then I can graph that up here. That's Y, money received. Okay, you always want to have an X and a Y label. Okay, now it's pretty easy to graph. If I sell 2 candy bars, then I will receive $3. If I sell 4 candy bars, I will receive $6. Keep going, see if you can get the next ones. Okay, hopefully you're noticing something. Hopefully you're noticing a pattern. In order to talk about proportionality on this graph, we have to know what something called the origin is. If you think of origin, origin can be used to describe like someone's nationality or a word. It has to do with where something came from or where it started originally. See how the word original or originally is in there? Hopefully you remember that 0, 0 is called the origin. What does that mean for this problem? 0, 0 is not in my table, but it could be in my table. What does that mean, or in the context of this problem? 0, 0 means if no candy bars are sold, no money is received. Okay, so maybe you've done this before where you've been in a club or a sport or something and you've had to sell items. Maybe you even sold candy bars and you had to collect a certain amount of money. So if no candy bars are sold, then no money is received. And that's actually represented right here. You could put your finger on this dot and say, okay, if I sell 6 candy bars, then $9 would be received. That's the proportion here. What does 1 candy bar cost? In order to do that, we're going to draw a line. So this is where I want you to get your ruler or your straight edge, whatever it is, and I want you to actually draw a straight line that connects all your dots. If you notice, it starts here and it does make a straight line going all the way through. You want to put a little arrow on the end to say that it goes on forever and ever. Because I can sell more than that. I can sell more than, let's see, we've got 8 candy bars. I can sell more than 8. Okay, so if you can tell here, this makes a straight line. So now, look at where the 1 is. 1 candy bar. Where is that? That's in between 1 and 2. What's halfway between 1 and 2? It is our unit rate right here. Remember when we figured out that $3 divided by 2 candy bars was 1.5? That's exactly what we figured out, that each candy bar costs $1.50. So let's go ahead and write that as a unit rate, $1.50 per candy bar. And there you go. We tied together unit rate, proportionality, and we showed it with graphing. This is a proportional graph, and we're going to talk about in just a minute. The way we can determine if it's proportional is it has to go through this origin, which we just talked about. So the line has to go through 0, 0, and it has to be straight through all the points. It can't be straight and then go in another direction and then go in another direction. It has to keep going in a perfectly straight line the whole way. So those are 2 things. Okay, on the next page, example 2. Let's look at this graph. Go ahead and graph those points. Pause it if you need to. Graph your points. We already have the labels on there, so that was nice that you don't have to rewrite those. Same scenario, different numbers. Pause it and graph these. Okay, if you're ready to unpause, here we go. 2 candy bars is $3. 4 candy bars is $5. 8 candy bars is $9. And 12 candy bars is $12. Should be a clue already if 2 of the numbers are the same and the other ones are different. So, like we were doing before, you can do 3 divided by 2, 5 divided by 4, 9 divided by 8. These are not going to give me the same answer. those are not going to give me the same number every time. But the cool thing about the graph is there's an easier way to represent that. So go ahead and try to connect these using your straight line. I'm going to try it over here. Okay, here's my line. Let's go with the one I was using before. Okay, if I start here, can I make a straight line that goes through all the points? Look what happens. If I try to go through those ones, it looks pretty straight, but it's missing that outer one. And if I go there, see, so I would have to keep making individual straight lines. And I can tell that they're kind of like different steepness. That's not a straight line. And if I kept it going, it doesn't look like it's going to go through 0, 0. Even though 0, 0 could be a point, this does not make a straight line. Okay, so does this table represent a proportional relationship? The table is no, because there is no constant multiple. Remember, your proof is right there where we did these division problems, so you can always draw a line there. We did 3 divided by 2 and 5 divided by 4, and it just wasn't working. That number isn't the same for all of them. Then we look at the graph. Does the graph represent a proportional relationship? If the table didn't represent a proportional relationship, the graph shouldn't either. How can we tell? Well, we just did all the points. When we connected the points, sorry, let's go ahead and put the word no, because it does ask us, is it a proportional relationship? So no, because when we connected the lines, oops, sorry about that. Let me clean this up for you. Okay. When we connected the points, it did not make one straight line. So remember, I'll say it one more time, and this is actually going to be good for your summary. So when you get to class, in our next class, you're going to say, oh yeah, this was the part that we could put in the summary. It needs to go through the origin and make a straight line. So this one obviously doesn't make a straight line. Okay, on to example 3, the last one. Go ahead and graph the points. Hopefully you're getting better at this. It's coming back to you if it's been a while since you've graphed. These are all positive numbers though, so hopefully if you just keep your x's and y's in order, you'll realize that it's pretty easy and hopefully it's coming back to you. Okay, keep graphing. Ooh, when x is 3, y is 9. So 9's not on there, but look at that. It's just halfway between 8 and 10. So there's x is 3, y is 9. Okay, keep going. 6 and 12. 9 and 15. Again, 15 isn't quite on there, but it's just halfway between 14 and 16. And the last one is 12 and 18. Okay, those dots look like they're all in a straight line, but let's just go ahead and double check. Do they all go through this line? Yes, they do. What is the problem though here? There's going to be something here that tells us it's not proportional. Okay, how are the graphs of the data points in examples 1 and 2 similar? And how are they different? So they're asking for examples 1 and 2. We're just going to say this one. You don't need to write this down. Okay, so let's just put a big parentheses around this. For examples 1 and 2, they do pass through the origin. Okay, one has a straight line and one doesn't. What I want to know is for example 3, we're going to write in this question, does this graph, I'm going to move this so it's not right here in the middle of nowhere. Okay, sorry about that. Looks like I had some mouse issues. Okay, does this graph represent a proportional relationship? How do you know? Okay, remember, in order to be a proportional relationship, this is going to be in your summary. So again, I've said this a lot, and this will be what you do as soon as you get to our next class. Okay, it has to go through the origin, and it has to be a straight line. So does this satisfy both of those things? Does it go through the origin? No. So you don't even have to figure out the next part, because if it doesn't go through the origin, it is not proportional. Now, it does make a straight line. Okay, that's great, but that still doesn't make it proportional. Okay, so the answer is no, because it does not pass through the origin. And go ahead and label that 0, 0, so you know that the origin is 0, 0. Okay, it is a straight line. It doesn't pass through the origin. Now, you could always divide and see what happens. 6 divided by 0, well, that's actually not going to give you something in your calculator. 9 divided by 3, 12 divided by 6. Some of these are basic math problems. You can already tell that the answers are not going to be the same for these. That's 12. Okay, so again, that's how you can prove it in the table. And then when you look over on your graph, it doesn't go through this 0, 0 right here, so it is not proportional. Okay, make sure that when you come to our next class that you're going to be doing the summary as your warm-up. So the summary is going to answer our essential question of how can I tell if two quantities are proportional to each other by graphing on a coordinate plane. Okay, and that is a wrap for lesson 5.